Okay, so it will form salts. Okay, a very soluble salt. So this one, that is what we call it as alkoxide. This one. So because it is attached to sodium, the metal usually what we use is group 1 metal. We don't, very seldom that we use group 2 metal. Most of the time it's like sodium or potassium. Okay, lithium is like maybe it will be too explosive, or it will be not reacting at all, kan? So we don't use that. So we use sodium or potassium usually most of the cases. Okay, so in this case we have this OH bond is broken, so hydrogen is replaced by sodium atom, and this is your salt. Okay, that we call as sodium alkoxide. If this is potassium, then it becomes potassium alkoxide. This is the alkoxide that we are forming. And the most important observation is the hydrogen gas that is evolved. Okay, so this one, it can be used as a test for the presence of OH group in a compound. So sometimes they ask you to test your product. Okay, so when you have this compound, okay, you test, you use sodium, this can be used. So when hydrogen is evolved, okay, so that shows that there is alcohol. Okay, and alkoxides, can you see this one, this
Yes.
equation down here? Okay, alkoxides are white solids which dissolve readily in water to yield an alkaline solution. Okay, so this is your alkaline solution, sodium hydroxide there. So sodium ion dissolve, become sodium hydroxide, and this one becomes back your ethanol lah.
So if you want to test for alkoxide, we add water and it dissolves.
No, not in terms of dissolve, you cannot do the observation.
Yeah, litmus paper.
No, it can be litmus paper, but then the most important thing is this one, the hydrogen gas.
I see.
This one is not that important.
Okay.
You can use, yes, you are right, you can use litmus paper, but then the most important observation is this one. Gas is evolved. Okay, and if you want to further your test, then you can use litmus paper. But the most important thing is this one, hydrogen gas. This arrow is showing that hydrogen gas is being released. Instead of putting gas in terms of the condition, so or the state, so you just put the arrow going outwards. That shows that the hydrogen is in the form of gas and it will be released. Okay, so this is a very important, or very one of the important tests for alcohol, because sometimes you are supposed to differentiate between alcohol and there is another compound that has only one oxygen, kan? Like aldehydes or ketones. This is one of the reaction that can differentiate between those three. Okay, or you want to differentiate between alcohol and carboxylic acid. Carboxylic acid will react with sodium. Okay, no, cannot. Sorry. Okay, done for this one?
Yes.
Okay. Alright, formation of esters. The other one, esters. Now, you are very familiar with ester, right?
Yes.
You have learned esterification, okay? But actually there are two ways that you can form esters. The first one is the one that is very common to you, which is alcohol and carboxylic acid, isn't it?
Yeah.
So these two are very common to you. Okay, alcohol and carboxylic acid. So, but then you have to remember, when you want to do this one, you have to reflux. Okay, reflux, and then you have to use a strong acid as a catalyst. If you just put these two together and expecting this to happen, to form ester, you will need a lot more time. So you need acid and heat to catalyze the reaction. So in a general way, or in general formula, this is your carboxylic acid. R, and this is you have to know okay how to join them together, okay, because this formation of esters is involve the fission of, for alcohol, the OH fission. This bond is broken. So for carboxylic acid, this bond will be broken. So these two will form water. Okay, so this two is out you go, and this one, the O, will form with this carbon. Get it? Okay, so that is why it is different color. So to show that this is where it is broken and this is why it is broken. Okay, so you have to continue with the O and the carbon here. Okay, and this is how you do your esterification lah, actually. Okay, so we reflux in and heat. Okay, heated under reflux here. Okay, and then this is your ethanol, if you are using ethanol, and your acid as your catalyst is here, sulfuric acid, and this is your ethanol acid. So it is being added slowly, okay, slowly together there, and then it will be reflux, and what you get is your ester here. Okay, so this is your condenser.
Teacher,
Yes.
carboxylic acid is an acid. So why doesn't it release H only?
Why does it?
Why does it release OH not H?
Carboxylic acid. Oh, carboxylic acid. Okay, so this is something very, that's why I said carboxylic acid is a weak acid. It is a weak acid. So it may release hydrogen, it may not release hydrogen. Same thing like alcohol. Sometimes it will release here, sometimes it will be broken here. That's the function of weak acid. Okay, that's why it is a weak acid. Sometimes it can be acid, it can be also base. If not, because when you compare between carboxylic acid and alcohol, logically carboxylic acid lah will break this hydrogen kan, logically, because when you compare between these two, carboxylic acid is a stronger acid, and then that's how it is lah. So I cannot explain more than that. I also don't know, just frankly speaking. Okay, so this is okay. Now for to name the ester. Okay, to name the ester, you have to know how to name the ester. Alright, please take note how to name the ester. Alright, so the name of the ester will be apa tu, alkyl alkanoate. I forgot to add in that one. The name will be ester, for ester. The name will be alkyl. Aduh, teruknya. Alkyl alkanoate. Ni aduh, alkanoate, OATE. Okay, berjaya. Alkyl alkanoate. So the part where it is alkyl is from alcohol. This is from alcohol, and this one is from your carboxylic acid. Okay, so as an example, if your alcohol is methanol, for example, your alcohol is methanol and your carboxylic acid is ethanoic acid, so the name of your ester will become
Methyl ethanoate.
yes, methyl ethanoate. Okay, let's say your alcohol is propanol. Your alcohol is propanol. Your carboxylic acid is methanoic acid.
Propyl methanoate.
Yes, it will become propyl methanol. Very simple lah. So that is why it is very important for you to know which part is alcohol and which part is your carboxylic acid. And you have to join them together. Okay, as an example, here, ya Allah, apa jadi ni?
Rajin.
Aduh, because last night is just suddenly off. I did save, but then I don't know what happened when I was asleep. This thing happened. Okay, so between alcohol and still the same. So example of ethanoic acid and propanol. So we have propanol and ethanoic acid. So from the equation there, so we have ethanoic acid here. So ethanoic acid, the fission will be CNO, and propanol will be ONH, the fission. So this one will become water. Okay. Oh, ni water. Okay. And the rest of it will be joined. So the name will be, because the name of the alcohol is propanol, so it become propyl. The name of the acid is ethanoic. So propyl ethanoate. So try to practice to write the name of this apa ni ester. Very easy kan. You have to just to write what is the structure for the alcohol and what is the structure of ethanol carboxylic acid. Sometimes you are given the name of the ester and you have to name the name of the alcohol and also the carboxylic acid. So you should know lah. You won't get wrong if the name is ethyl ethanoate. Both will be the same. Or propyl propanoate, both will be the same. Okay, you get wrong when you don't know much about, like for example in this case propyl ethanoate, and how do you write this one? Okay.
Okay.
Okay. Oi, terbang pula. Okay, the second way of formation of esters. Oi, this is not. Sorry. Yes, ester is by the reaction of with acyl chlorides. Okay, this is acyl chloride. It move as they please lah. These things. Aduh, I was late this morning to double check the flights. Okay, reaction with acyl chloride. This is your acyl chloride. Acyl chloride is the apa ni? What is the word? What is the word? Derivatives.
Okay.
Derivatives of carboxylic acid. So you see here, you have, it looks like a carboxylic acid kan? But when it is carboxylic acid, it is COOH. Right? So the OH is replaced by X. So this is an alkyl group. We call it as alkyl group. So when this X is chloride, so it will become acyl chlorides. If it is Br, so it become acyl bromides. Okay. So in this case, we are talking about acyl chloride lah, because that is the most active one. Okay, so if acyl chloride, this is your acyl chloride, reacts with your alcohol. So the same thing, the alcohol, okay, the fission is here. Okay, between O and H. It is still under the same fission kan. The OH is broken The O will be here and the rest of the R. So this O is from alcohol. So you still get ester, ester. The naming is still the same. How you name this ester, although it is from acetic chloride, the name is still the same. Okay, so for this ester, let's say the alcohol is ethanol, and this one there is only let's say we have three carbons here, propyl that is, what is the name, propyl chloride. Okay, propyl chloride. No, sorry, propanoyl chloride. Propyl chloride. Propanoyl chloride. Okay, so the name of the ester will be ethyl propanoate. Something like that. So I'll give you the example lah. Dah hilang pula dah. Can I break? Break, 5 minutes break.
Okay.
Let me look at my good